In this part, we're going to try to resolve this problem from LeetCode. Problem number 587, erect the fence. The problem statement is here. As you see, you are given an array trees where t's of I is xy, xi, yi represents the location of a tree in a garden. You are asked to fence the entire garden using the minimum number of length of rope, as it is expensive. The garden is well fenced only if all trees are enclosed. Return the coordinates of trees that are exactly located on the fence parameter. As you see, we can reduce this to compute the convex hull of all these points. First, we're going to use the brute force algorithm seen in the previous part to resolve this problem. Of course, it's not efficient. The problem or the result of this problem using the brute force algorithm will be time limit exceeded, as we will see later. Now first, we're going to pick every time 2 points. This two loops is for picking every time the 2 points, point 0 and 1, and point 0 and 1, sorry, point 0 and 2, 0 and 3, etc., and 1 and 2, 1, 3, 1, 4, etc. Here, donc we go and reach n minus 1, because here we took I plus 1. We're going to check if the point trees of I and trees of J, these are the 2 points. We're going to check if the rest of points is on the same side or not. That's why we're going to use, of course, the vector trees here, which contain all the points. Okay, we're going to implement a function. Let's call it R all on the same side. It will return true if all the rest of points are on the same side of the line built by the, for this point try t is to E and this point t is to J. Now F here. Of course, we're going to implement this function later. If yes, I'm going to store this 2 points in a set of points. We're going to use a set here for not duplicating a point. Let's do that. Insert trees of I. This is the first point. Then trees of J. If trees of I is already exist, it will not be inserted, because in C++ this is a set. In a set we cannot find two objects have the same value. Then we're going to return here a vector, or let's like this directly. We can say S a vector here, vector of int. Let's call it whole, which is s begin, s dot end, like this. We cannot convert. We're going to convert here the set to a vector of vectors. Let's implement this function. The two picked point A and the other picked point B. This is the line. This is the line drawn by point A and point B. As we have said in the previous part, we have to compute the number of points in the same site by adding 1 if the cross product is positive, reducing 1 if the cross product is negative. First is equal to 0. We have to compute also the number of points on the same line. Run over the rest of points. Of course, here the current point must be different of A, different of A and B. Computing the cross product, we're gonna build another function here for the cross product. A to B, the point P. Here, we're going to move from A to B this is the direction of the line. We're going to compute the orientation of the point B with respect of AB, the line AB. If the cross product is positive, then we add 1 to this, else if the cross product is negative, reduce 1 from the number of points on the same side, else neither negative or positive, so null. We're going to add on the same line 1. This function will return the number of points on the same side plus the number of points on the same line is equal to n minus 2 or not, or sorry for this, minus ambiguous number of points on the same side minus number of points on the same line is equal to minus n minus 2. I think we have to put this between braces. And be on the same side. Here. N is not found here. Okay, we have to n is equal to trees both sides. Okay, A is B. Let's implement the function cross product. We have a point here, int so we have a vector, not a point. So pair this is the vector u. This is the vector v. I'm sorry, here we have point, not vectors. Point A, point B, and let's say a point, the current point, let's call it C. We have to compute the determinant of BC or CB times CA. And the vector here, vector, let's do this in comment, vector CB times vector CA. How to find this determinant? Let's compute the coordinates here. XC is equal to C 0, YC is C1. This is the point, this is the first component of the vector CB. XB, YB. Here we have B and B. Okay. The determinant, let's call it Z, sorry, is equal to vector CB, which is CB CB is XB minus XB minus XC. Yeah, let's do it here. We have CB times CA, vector CB times CA, because we have a point A and a point B here, point A and a point B. We want to know the rotation of this point by respect of this line. CB times CA is correct, which is XB minus XC here, the first component of the vector CB. The second component of the vector CB is YB minus YC. The first component of CA is XA minus XC. The second component of CA is YA minus YC. The determinant is XB minus XC times YA minus YC. XB minus XC times what? YA YC. Minus XA XC times YB YC. Turn Z. let's check the let's test this code for the samples first before submitting the entire solution. And B on the same side is not defined here. Okay, and this one. Okay, identify trees is not defined. Vector or vector of int. I don't know why it's not defined here. Trees. This function. Okay, let's try it. Sorry, default case. What's going on here? Let's try it again. Voila. Implicitly deal before constructing. I think to be just a set. Okay. Okay, this one here. Which one? Here, expression. This one return Z, return Z. Maybe here. Sorry, here return all. Let's say if it's correct or not. It's not in the same order. It's okay. Any answer, any correct answer is accepted, despite of the order here. 1 1 is here, 2 0 is here, 2 2 2 is not in the convex hole here. Why? Okay. Why 2 2 is in the convex hole? It shouldn't. 2 2. here. Frankly, I did not figure out what's the problem here. Y22 is the convex hull for my output here. This is the correct answer. Let's check it together. Here, xb minus xc, xb minus xc times ya yc. YC. The other one, XA minus XC, XB minus YC, YB minus YC. Let's try it again. One one 2 0 2 4 3 3 4 2. I think it's okay. Let's submit it. We have a wrong answer here. Okay. This tree, this garden contains only one tree. The answer should be 1 5. My output here is wrong. Here we come here and say if and okay, for 1 point this is the convex hull. For 2 point this is the convex hull. See here, for 1 point this is the convex hull. 2 points this is the convex hull. For 3 points, for 2 points this is the convex hull. The 3 points also is the convex hull. Return trees. Okay. Let's submit again. Okay. As you see, the time complexity of the entire code here is O, is big O and Q. Is not efficient at all. That's why we have here a time limit exceeded. In the next part, we're going to see another algorithm, which is Graham-Scan algorithm combined with the divide and conquer concept. See you later.